The next singularity function is the unit ramp function. Okay, so that's what we would like to talk about now. This is also a causal signal like u of t. Okay, it is 0 for negative values of t. Okay, so it is denoted by r of t, and it is defined as it is equal to t when t greater than or equal to 0 and 0 if t takes negative values of time. Okay, so it is clear that its waveform would be like this. This is t, and with slope, unit slope in x axis 1 unit, then in the y axis also 1 unit. So this is my r of t and this is time axis. Okay, it has value 1 when t is equal to 1. So for positive t it is described as t, and for negative values it is 0. This is called a ramp function r of t, because this is like, this one is like a ramp. It is called a ramp function, and since the slope is equal to unity, it is called unit ramp function. It looks like a ramp and the slope is unity, so therefore it is unit ramp function. Okay. Now let me denote the slope within a bracket by like this. Okay, so it rises by 1 unit or unit amount. So this is called a unit step function. Okay, now let me illustrate its applications through some examples. So sequence of examples we will consider now, and then we will illustrate this one. Now if I take a function which is delayed by 1 unit, it is 0 up to 1 unit, and then it has slope of 1. Okay, so how do you write this function? Okay, now if you look at the definition of r of t, it has it has non-zero value when t is positive, right? If t is greater than or equal to 0, then this has the value of t, that is non-zero value. This is non-zero value, right? And it has a zero value when the argument is negative. When this argument is negative, whenever the argument of the ramp function is negative, then its value is 0. So here also up to this point it is 0. Therefore up to this you have to put something within a bracket such that it should be negative. That's it. Okay, now if I put t, then it will not be negative if I put t equal to 0.5. If I write r of t, this function, suppose in case if I write like r of t, then r of 0.5, I should get some non-zero value. But here I have a 0 value, right? Therefore somehow I need to modify that. So what will I do? What I will do is I will put, let me put r of t minus 1, so delayed by 1 unit of time. Now you can check it out. R of t minus 1, put t is equal to 0.5, then r of 0.5 minus 1, this is r of minus 0.5. Since the argument is negative, then its value is 0. So you can see the value is 0 here when t is equal to minus 5. The moment you put let us say t is equal to 2, then r of 2 minus 1, because r of t minus 1, so r of 2 minus 1 which is r of 1, and this 1 is positive, the argument is positive, therefore its value is non-zero. That is, you can look at here. So this function is better described by r of t minus 1, like this. Okay. And this function has 0 for t less than 1. Up to this point it is 0, and increases at the rate of 1 unit per unit distance travelled along the x-axis. Then this would be called r of t minus 1, because it is the same unit ramp function shifted in time towards the right, that is delayed in time by 1 unit. Okay. Therefore, this will be r of t minus 1. We should be able to recognize that whenever a function is delayed by an amount, let us say tau, then that function is written by x of t minus tau. That is delayed version of the x of t. If it is advanced, then you should write x of t plus 2. It is an advanced signal. Now let me take another example. I have a ramp function. It starts at 1, but now it does not have positive slope, but it has a minus slope, negative slope, like this, minus 1. The slope is negative. Okay. So this function is 0 up to this point, and then it goes down, negative slope. Okay. So therefore at t equals 2, the slope is, this point is 1. Okay, because slope of the signal is 1, therefore at 1 its value is 0, at 2 its value is 1, and it is not plus 1, it is minus 1. So therefore the ramp function starts at 1, so it is a delayed signal, right. So let me write r of t minus 1, delayed signal. Since the slope is negative, so I am putting 1 minus symbol here. So this is the function for this guy. That is how you describe the ramp function. Let me take another example like this. I am sorry, this should not come, like this. This point is, let us say 3, and this point is, now it is not 3, it is 9. Okay, if you have a function like this, first you find the slope of the signal. What is the slope? So this point is 0, 9, and this point is 3, 0. What is the slope? Let us say this is x1, y1, x2, y2. So y2 minus y1, 0 minus 9, divided by x2 minus x1, 3 minus 0. So minus 9 by 3, minus 3. So the slope is minus 3. So minus 3 times. Now you should write r of something. So this point you have to figure out what it will come. Okay. So this function is 0 beyond 3 in the positive direction. This is positive direction. Okay. And then it increases in the negative direction. See, it is increasing in the negative direction. It is going like this. The function is increasing in the negative direction. So therefore the slope is, as we already found, minus 3. So if you are unable to find out explicitly by looking at the figure, then simply apply the slope formula, like find out 2 points, then name it x1, y1, x2, y2, recall from your school mathematics, probably 9th standard or 10th standard, then find out the slope. Slope is equal to y2 minus y1 divided by x2 minus x1. So the slope is negative, minus 3. Therefore, as t increases, the slope is minus 3. It leads to a ramp function which has values for less than 3. Okay. It has a ramp function for t less than 3. Okay. So this function is a time reversal function. First of all, you reverse by t. Instead of r of t, you have r of minus t, because it is increasing the negative direction and it is shifted to the right. Therefore, r of minus t, okay, and plus 3. So, because negative function shifted to the right, therefore this plus comes. So, r wise I can write r of 3 minus t. What is the slope here? The slope is minus 3. So, this function is minus 3 times r of 3 minus t. In case if the function goes like this, then it is r of t minus 3 will come. Okay, but the function goes like this, therefore r, it is time reverse. 1 minute, I don't want to confuse it, let me draw. But the function, 1 minute, I am sorry. If the function goes like this, r of t plus 3, this is, let us say this point is 9 and this point is 3, then 3 times r of t plus 3. Okay, if you have like this, then it is r of t. If you draw the function like this, then it is r of minus t. If you shift to the right hand side, then if you recall from our unit step function, this is r of minus t plus 3, and the slope here is minus 3. Therefore, minus 3 times r of minus 3 times r of minus t plus 3. That's it. Okay, because if it if t exceeds 3, this becomes negative. Okay, this guy becomes negative, and this becomes 0 here. This is 3 and this is 9. Very simple to describe. Okay, let me consider another example. One second, this I did something mistake here. What did I do? y2 minus y1 divided by x2 minus x1. Okay, the slope is 3 minus 3, but it is now increasing in this direction. Okay, it is negative slope, but that slope will not, this minus sign will not come here, because it is now always positive. It is not going to the, actually wait a minute, I confused a little. If you have a ramp like this, then you put minus r of t. Okay, if it goes like this, then it is plus r of t. Okay, first of all, let me clarify one thing. This is r of t, then this is minus r of t. If you have the function like this, then this one is r of minus t. Okay, if you have a function like this, then it is minus r of minus t. So similarly, this one is going up like this. It is delayed version of this guy. Therefore, this is, its slope is 3 times r of minus t plus 3. So this minus will not come. I am sorry, this minus will not come. Okay, so please remember, this minus will not come. I told you wrongly, so don't consider this. The slope is negative, that I agree, but that's it. Let me consider another example. like this. Let's say this is minus 1 and this is plus 1. Okay, it's a triangular wave shape. Okay, this function is of the form of triangular, which you can decompose as follows. As I said, always start from the first step, first jump. So at this point it is 0 up to this point, and then there is a sudden jump of with a slope, not sudden jump, with a slope of 1. Okay, at t equal to minus 1 there is a ramp. This ramp is there at t equal to minus 1. So how do you describe that ramp? So it increases like this, and again this point is 4. Okay, so if you have a signal like this, then it is r of t. If you advance a signal like this, then it is r of t plus that advanced amount 1. So therefore this function is r of t plus 4. Now you find the slope. The slope is 4 units. So this function is 4 times r of t plus 3. Okay, the moment you reach this point, you have to come down. You are not allowed to increase. Therefore what you do at this point at t equal to 0, you introduce one slope with the because already have 4 units of increasing. Okay, okay, then you have to bring it downwards at t equal to 0 onwards. So how will you do that? In order to pull this portion down, to pull down, we introduce a resultant slope of minus 4 at this point. Okay, so here you have minus 4 unit of slope, and here you have increasing plus 4. So totally I need 8 units slope, minus 8 units. That 4 unit slope will be compensated in this guy, and if you introduce only 4 units, then what will happen? It becomes horizontal line. I don't want horizontal line, I need to come back. So that's why I put minus 8 here. So this one is minus 8 of r of, it's in the positive side, it is t, minus 8 times r of t. Okay, if you add these two guys, then you will get a signal like this. It goes up to this point 4, this is minus 1. So this is described by 4 times r of t plus 1, then it comes down like this. Okay, so this is what you call minus 4 now, and this also minus 4. So now I want to bring this guy to 0. This is plus 1. I want to bring this guy to 0 after plus 1 point. So what shall I do? Exactly at this point you introduce another slope with 4 units positive slope. Okay, now how do you describe this? It is delayed by 1 unit. Therefore r of t minus 1. What is the slope? 4 units. So I put 4 units. So add this and that, this one and this one, 1 and 2, then this slope will be arrested. So it goes like this, come back, and it becomes horizontal line. So this is minus 1 and this is plus 1, and this is 4 unit, and this one is 4 times r of t plus 1, and this one is minus 8 times r of t plus 4 times r of t minus 1. Okay, to arrest the downward slope at, to arrest this downward slope, we must put this back to 0. You introduce this slope. Okay, so that means this slope must be stopped after t is equal to plus 1. Okay, then it must be restored to a slope of 0. Therefore at t equals 1, you must introduce another ramp. this ramp, okay, with a positive slope of 4 units. That ramp is denoted by, it's a delayed ramp, so 4 times of r of t minus 1. Now this ramp and this ramp will add each other, will cancel each other, will add, if you add it, then it will cancel each other, and finally you will get a triangle like this. Therefore, at t equal to 1, at t equals 1 onwards, you will get a 0. Okay, so this particular triangle is described by 4 times r of t plus 1, this guy, and this guy is minus 8 times r of t, right, plus, to bring back to 0, if we introduced another ramp with this guy, so plus 4 times r of delayed version r of t minus 1. So this is how the ramp function can be employed. Okay. Now there is an important note you should remember, that says r of t is not equal to t. Okay, they are not the same. This function and this function are not the same. R of t is defined only when t greater than 0, but this t is defined for any values of time. So what is a typical plot of t? It looks like this. When t greater than 0, it increases linearly. When t less than 0, it decreases linearly. So this is a t plot. Okay, when y of t is equal to t, then it looks like that. But what about r of t? R of t is defined only for positive values of time, and negative values of time it is 0. Now if you recall from your unit step function, the relation between t and r of t is written as follows, because you cut off this portion. How do you cut off? You multiply from this portion onwards by 1. From this portion you multiply by 1, and this portion you multiply 0. There is one signal which has 1 in the positive side and a 0 in the negative side. Which function is that? That one is u of t. See, u of t has 0 value in the negative side when t less than 0 and plus 1 when t greater than 0. Therefore, you take this guy, multiply by your unit step function like this. So here 0 and here some non-zero value. So if you multiply these two guys, then it is 0 here, and here it is 1, and 1 into the slope, it is a slope. Therefore, your r of t is equal to t times u of t. So that is the definition for unit ramp function. Okay. So r of t is 0 for t less than 0 and t when t greater than or equal to 0. Therefore, finally you can write like this. Okay, because if you multiply t by u of t, the negative values will be multiplied by 0. This one. See, this is the negative value, and this negative value will be multiplied by this 0. So it gets cancelled out, and for positive t, this positive t gets multiplied by this slope. So r of t can be alternately written, if you wish, as r of t is equal to t times u of t. In this way you can write down. Okay, simply you cannot write r of t equal to t. This is wrong, completely wrong. Don't write like this. Okay, r of t cannot be equal to t by itself. Okay, so that's all about unit ramp function. So in the next lecture we will talk about unit impulse function. Thank you very much.